What if Yellowstone erupted today? Not hype. A scientific scenario step by step. This is the Yellowstone supervolcano beneath the northwestern United States. Here is what could happen. And why. Yellowstone sits atop a volcanic caldera spanning parts of Wyoming, Idaho, and Montana. The caldera measures roughly 45 by 65 kilometers. Much of it is subtle at the surface, until you map the edges. Beneath, the system is active. A supervolcano is not a giant cone. It is a large, long-lived magma system. It can produce a VEI-8 eruption, hundreds to thousands of cubic kilometers of ejecta. Yellowstone had caldera events about 2.08 million, 1.3 million, and 631,000 years ago. Today, frequent small earthquakes and heat flow reflect an evolving system, not a schedule. Imaging reveals a complex reservoir, mostly crystal-rich mush, with interlinked melt pockets. Seismic waves travel slower through melt, outlining where magma and gases collect. As pressure changes, dissolved water and CO2 form bubbles, increasing internal pressure. Uplift, quakes, and gas emissions would likely intensify before any large eruption. But most unrest does not culminate in a super eruption. In a worst case, an explosive opening blasts a Plinian column into the stratosphere. The column forms an umbrella cloud that spreads laterally with jet stream winds. Coarse fragments fall near the vent. Fine ash can travel thousands of kilometers. Within hours, ash rides prevailing winds across the central and eastern United States. Stratospheric transport can encircle the hemisphere in days to weeks. Ash thickness decreases with distance, but even millimeters matter for infrastructure. Near the caldera, pyroclastic flows surge outward at highway to jet speeds. They are extremely hot and fast, devastating tens of kilometers in minutes. Topography guides flows down valleys, concentrating impacts. They leave welded ash flow tufts, ignimbrites. Eruptions release water vapor, carbon dioxide, sulfur dioxide, and other gases. SO2 converts to sulfate aerosols, reflecting sunlight and cooling the surface. CO2 can accumulate in depressions locally, displacing breathable air. Heavy ash would blanket Wyoming, Idaho, and Montana, with significant falls into the Great Plains. Lighter ash could reach the Midwest and East, depending on wind patterns. Ash is abrasive, conductive when wet, and cripples engines and electronics. Even a few centimeters can overload roofs, especially when saturated by rain. Ash clouds water systems, requiring extensive filtration and flushing. Air travel would halt across wide regions. Ash can flame out jet engines. Major airports close until ash concentrations drop and runways are cleared. Agriculture suffers from leaf abrasion, blocked photosynthesis, and soil pH shifts. Livestock need protected water and feed. Ash ingestion is hazardous. Water utilities face turbidity spikes and chemical imbalances. Sunlight would dim under ash and aerosol haze, reducing solar power and lowering surface temperatures. Large sulfur releases can trigger short-term global cooling, volcanic winter. Models suggest cooling of roughly half to 2 degrees Celsius for 1 to several years. Yellowstone is monitored closely. The odds of a super eruption any given year are very low, but the science prepares us.